Question 20 reads, if the 5 line segments in the figure above are all congruent, what is the ratio of the length of line segment AC to the length of line segment BD? This is a rather tricky quadrilaterals problem, and to get started, let's actually draw this AC line segment. There we go. And we want to find the ratio of AC to BD, so these are the 2 diagonals of this rhombus. Now, because we're interested in these 2 diagonals of this rhombus, a formula should come to mind that involves both diagonals of a rhombus, and that's of course the formula for its area. So the area of this rhombus can be written as diagonal 1 times diagonal 2 over 2. So that's at least one equation that relates these two. Now, right now, we don't have any variables assigned to these lengths or numbers assigned to these lengths, so to make life a little bit easier, I'm going to assign some variables to these lengths. So I'm going to call the unknown line segment AC length X. I'm going to call the known one A. Now remember, because all the line segments are congruent, that means that these side lengths are also A. Okay, so now we can sub these values into the formula that we know for the area. We'll have diagonal 1 be X, diagonal 2 be A, and divided by 2. Of course, this doesn't help us find the ratio of X to A, which is what we're looking for, right? The ratio of the length of the 2 diagonals. We're going to need another formula that involves these 2 variables. So there's more than one way to find the area of a rhombus. You can also find, that should be base times height, just like any other quadrilateral. We know the length of the base, it's A. The trouble is finding the height. So the base is A, the height we're not sure of. This is where being a little bit tricky comes in. Note, this figure is not drawn to scale, so what you're seeing here can be a little deceptive. Go with what you know is true geometrically. If this length is A, and this one's A, and this one's A, then that is an equilateral triangle. So, if we're trying to find the height of this quadrilateral, it's also just the height of an equilateral triangle whose side lengths are all A. In order to find the height of an equilateral triangle, remember, you just drop down the altitude, and now you have a 30, 60, 90 right triangle. So, based on what we know about 30, 60, 90 right triangles, this altitude here is whatever the value of A is, divided by 2, that'll give you this side, and then we multiply it by the square root of 3. That's the height of that equilateral triangle. Oops, that got a little bit cut off. That should be A over 2 times the square root of 3. That's better. So, using the 30, 60, 90 triangle relationship, we can find the height of this equilateral triangle, which is also the height of this rhombus. A over 2 times root 3. So now we're in business. We have 2 equations for the area of the rhombus, and we can set them equal to each other. So this equation for the area, base times height, works out to A squared over 2 times root 3. And this equation for the area works out to XA over 2. We're almost done. These 2's on the bottom cancel out on both sides, and we have 1A cancel out on both sides. So what you're left with is A times the square root of 3 is equal to X. So what is the question asking? What is the ratio of the length AC, that's A, to the length of BD? Oh, so sorry, that's X, to the length of BD, that's A. So we want the ratio X over A. So to get that from here, we'll divide both sides by A and get X over A is equal to the square root of 3 over 1. So the correct answer is B, the square root of 3 over 1.